Hello and welcome to another episode of Baz Codes. I'm your host, Baz, and today I'm going to talk a little bit about software archaeology, in a sense, not maybe in the same way that other people are, but in terms of this development that I've been doing the last couple weeks on my Apple II series emulator GS squared. I followed a very interesting trail of breadcrumbs through the past to achieve a really good solution to a problem I was facing. And I wanted to share that journey with you here today. I thought it was very interesting, and I hope you do too. So, as you know, I've been working on an Apple II series emulator I call GS squared. My intention is for it to be a emulator for the entire Apple II series, Apple II, II Plus, IIe, and that's where I'm at now with this development. Is I finished up the Apple IIe stuff a couple months ago, and I've been working on various enhancements to how I do video rendering, particularly. And I've started recently getting into support for getting into Apple IIgs emulation. So I've been working on super high-res modes that the Apple IIgs has, as well as, some other kind of things on the edge of that. So the Apple IIgs was released by Apple in 1986, and G and S in the model name stand for graphics and sound, because they really represented a huge leap in the capabilities of the Apple II platform, especially in those areas. The whole thing was a big lift, but graphics included new 320 by 200 pixel mode, as well as a 640 by 200 pixel mode, with potential colors from a palette of 16 colors typically. 4,000 different colors that you could select to put in the palette. So the color options and the simplicity of generating really nice images was really improved compared to the original Apple II. And it brought the GS into parity, and in some ways exceeded some of the other competing computers that were out there at the time. Of course, as we know, PCs rapidly eclipsed all of the other competition in those years by 88, 89, and but the Apple IIgs still has, a lot of cool abilities. So those new modes are pretty straightforward, and the reason is that the Apple IIgs supported RGB video output. So the ability to not just rely on the TV or composite monitor's interpretation of certain bit patterns, but really just telling the monitor, hey, I want this pixel to be exactly this color, and then moving along. So as an example of that, we've got, Apple IIgs had the ability to do images like this. This is a 320 by 200 in my emulators video routines. And then this is a 640 by 200. And this is GSOS, Apple II GS's operating system desktop mode. Basically, made it look like a Mac. And it had color way before the Mac did. Just FYI, Mac heads. This stuff is all relatively sensible in terms of emulation. It's a linear buffer. It doesn't have any of the weirdnesses of the original kind of Apple II high-res color mode. So that's great, right? But now the challenge was when creating the Apple IIgs, how do they maintain compatibility in this new environment with RGB monitors with the old Apple II video modes, which relied on NTSC, color tricks to generate images. Well, that was the question also for me as an emulator writer. And I did a good pass at that, I think, with the NTSC video. Oops, that is not what I meant to do. Ha ha ha. Okay, there we go. So this is the Venerable Choplifter game, doing my NTS simulation. You can see all these artifacts when transitioning between different colors. Solid areas are great, but going from like green to orange, there's shadows and all kinds of stuff. That's the beauty of this mode, taking advantage of its unique character allowed really amazing stuff, right? But how do you convert this to a modern display? And how do you have it look not like this, right? Because they wanted to upgrade the look of even old software for the Apple IIgs and make it as crisp and clear as, stuff like that. So that was my challenge as well. Now, I took a stab when I first started this project at writing what I called an RGB emulation. And it was okay. I didn't care for it. I didn't care for it a whole lot. And that's why I was revisiting it again. It did a reasonable job, and I think most emulators that are out there do a reasonable job, and we're kind of created the same way, which is to say we had an understanding of what output was supposed to be like, and we did our best to achieve that. But, there's thousands and thousands of potential state changes in this video data as it's streaming across. So you're either faced with, just working through those one at a time and staring at old screens and then back and forth, doing stare and compare. Or just, getting it kind of good enough and leaving it at that. So when I first started revisiting this and was doing the cycle accurate enhancements to my emulators video back in June, July, August, a contributor sent me something that I thought was very interesting, and that was this. This is a patent. Why aren't you? Come on, window. Why can't you get bigger? Let's try that. No. Okay, that's weird. Well, we'll just go with this. This is a U.S. patent granted to Apple in 1988. Now, it doesn't say Apple IIgs in here, but the title of the patent is spot on. It's method and apparatus, it's patent speak, for generating RGB color signals from composite digital video signal. Well, that sounds like exactly what the Apple IIgs is trying to do, or I should say it does what I'm trying to do. So I said, great, here's my roadmap to getting this feature done. Well, I beat my brains out with this patent several times, trying to implement the algorithm contained herein. And I get all this. Here's a bit stream coming out of the old Apple II video modes. I get that. That's basically what I did with the NTSC stuff. Oh, great. Look, here's a handy flowchart. Okay, detect change in color pattern. If there is a change, keep using the old color until the change has been consistent for a while. Okay, that makes a certain amount of sense. They even provided, some logic diagrams in here. Let me see if I can get rid of that is so weird. Oh, that's better. Okay. Here's a logic diagram of components. Okay, mux, barrel shifter, shift register. I get it. Um, well, I kind of got it. It took about 18 reads of this stuff. I hope every patent isn't written this obscurely. Maybe maybe they are. Maybe that's just how the people like patent stuff and have to publish all the methods, but then still protect them. Uh, Many times I took a stab at this and failed. I got pretty close a couple times. I have to say, this was the last um, result here. This isn't too bad, right? Okay, blue to black, green to black, oh, orange to green. That's a good transition. That's good. But what is going on here on these text characters? That is not happy. This is all smudgy and smeary, even though other parts of it are perfect, right? We've got nice, crisp transitions. Like in the middle here, it doesn't work. And I couldn't get this to work right. And I kept trying, and I thought it was me. And then I was chatting with another developer who had also tried to take this patent and implement a legacy Apple II video mode rendering, and they said they couldn't figure it out either. So I came to the conclusion, sadly, that the patent, while it included some of what was necessary to do this conversion, wasn't actually complete in terms of what got implemented in the Apple IIgs. So they probably took a snapshot of their development process, but it didn't include all of the tweaks and other add-ons that they had to do to get it into production in the Apple IIgs. So the patent wasn't going to be sufficient. And then I was back-faced looking at, manually tweaking this, experiment, tweak, stare and compare, which was the whole thing I was trying to avoid, because there's no way that's going to end up being accurate. So I did some thinking. I said, well, okay, I'll take a look at what maybe some other emulators have done. And I'd looked at some of those before. They were generally of like I said, the type where, the developers kind of estimated what the results should be and came out with code that does an okay job. But none of them were producing anything like what the Apple IIgs actually puts out. And then I remembered an emulator that never actually necessarily got put out in the world very much. It was the first Apple IIgs emulator. It was called Gus, Gus. And Gus was a project started by a bunch of Apple engineers in the mid-90s, working in their spare time, hoping that Apple would produce a distribution of it, to help Apple II, 2GS users migrate to the Macs. Ultimately, Apple never did anything with it. I think it was worked on from 94 to 96. And then Apple wouldn't do anything with it. And then certainly by the time Steve Jobs came back in 97, I'm sure he wanted nothing to do with it. So it kind of faded into obscurity. There was another Apple IIgs emulator that came out somewhere right in that time frame called Bernie to the Rescue, which ultimately became known as Sweet 16 when it was ported back to Mac by Eric Shepard, an old friend of mine. So I said, well, that's interesting. So this is Apple guys, right? If anybody knew what was going on in the Apple IIgs, it would be these guys. So I remembered that I had stumbled across source code for Gus. They had released it at some point. I don't think anybody knows exactly who released it. Maybe if you do, or if you're the one who did it, put it in the comments, because little foreshadowing here. Thank you. It was very interesting when I started digging into it. And so here is, nope, that's the wrong one. Here we go. Here's the Gus source code. So, Andy Nicholas was an Apple II aficionado who went to work for Apple in the, I think, early 90s. He was very active at the time. And so he's all over this. There are some other names that you might recognize that we'll come across here in just a minute. But I started reading these comments, here in the GS high-res and GS high-res table files in the Gus emulator. Dave Lyons, he was in developer support, I think. Mike Neal. Mike Neal is active today doing Apple II hardware and software projects. And Jim Murphy. I don't think I knew Jim. But anyway, I'm reading these comments, so I'll just dive in here. The basic idea is to get 11 bits worth of 2GS high-res or double high-res pixel data and look up the correct pixel colors in this table for 4 distinct Mac pixels. Now, this project, at the time, they were dealing with rather limited Mac hardware, which is to say, 68,000 based stuff. Not super fast. Good enough, but they were very cognizant of limitations here. So there's some things here that are optimizations. So 560 pixels across being the mimicked 2GS screen. Now, I read this and I said, aha, okay, so they're getting 11 bits worth of video data basically as a sliding window. So they're looking at the data stream coming out, and they're looking at a sliding window. And I recognize this because this is basically the approach that I took in the NTSC emulation code. You look at not just the current pixel and not just maybe recent pixels, but there's a look ahead that helps you determine what the color of the current pixels are supposed to be. And this is probably the key thing that Patton talks about, like looking ahead 1 dot, 4 dots ahead. But as we saw, that can't be enough to get the job done. So let's see. After each 4 pixel color values are figured out, the 11-bit window is advanced by 4 bits in the 2GS pixel data stream. Then the process is repeated. Yeah, so they're just talking about the sliding window there. This is basically talking about how to bit double the high-res bits, because regular Apple II high-res mode is 280 pixels, but the display hardware is actually 560 dots. So you've got to convert high-res information by doubling pixels and sometimes shifting them. And then I got to this paragraph, and this was really when a light bulb went off. According to John Archaeology, who wrote the original Apple IIe card code, which is, that's what this reference is here. Double exposure was the internal Apple code name for the Apple IIe card. Segue. The Apple IIe card was originally produced for Mac LC and certain other early Macs like that had a processor direct slot. It was basically 6502 and some custom glue chip on a card. You would stick it in a Mac. There's some companion software you run, and then you can run Apple IIe software directly in your Mac on an actual 6502. So it apparently used software running on the Mac to handle the translation of the Apple II display. So they had a minimum of stuff on the card. The card was generating these bit streams interpreted by software running on the Mac. And then that was that. So John Archaeology was a key player in that product. So he wrote a state machine for the set of PALs, programmable array logic, that were in the Mega 2, which decodes some lines into a color signal. So the Mega 2 is that magic chip inside an Apple IIgs that implements almost all of the Apple IIe logic, right? So it handles the Apple IIe display mode generation. It handles, the Apple IIe memory mapping and all of that stuff. So, I read this sentence and I'm just like, he did what? He did what now? He wrote a state machine for the set of PALs. So he simulated the logic in the Mega 2 from the Apple IIgs and then fed all possible values for each of these input lines, which makes me think there were 11 lines. Well, there were, because we have 11 bits here. He feeds 11 bits into the state machine and then recorded the value that was output for each possible input. So essentially, this guy simulated the operation of the Mega 2 chip from an Apple IIgs as it pertained to converting Apple II video modes to RGB. There are 2048 outputs because there were 11 lines of input. Yeah, 11 bits gets you a number up to 2048. And I would guess that also applies to some set of traces inside the Mega 2 in the 2GS. Now, I would have killed to get access to this. Who knows if any of this information is still even in existence anywhere. But this was brilliant, right? So by the time this project came out, I think this was it was like 92 or 93 maybe, the Apple IIe card. That's already seven close to 8 years after the Apple IIgs was produced. So for him he obviously had access to the logic, designs. And then to simulate the logic, all possible inputs generate the outputs. And the output, the output was what's in this file here. So here's our, that's not the one I want. This is what I want. Forget the last bit. Here's a table of 2048 possible inputs, 11 bits of input, and then the output as pixels and pixel colors. So instead of having to figure out the algorithm, well, this is the algorithm, all possible inputs and outputs. And I said, aha, there I go. Why don't I just take this table and stick it in my project? So that's what I did. That was really a eureka moment for me. So let's take a look at what that output looks like. Okay, so this is my attempt to do the patent, which did not work. All right. So this is this. Let's go down here. And I believe, yeah, I need to change this to that. And let's rebuild that real quick. Okay, this is still the old one here. All right. Switch to RGB mode, and voila. Oh, look at that. So not only are these weird artifacts over here no longer present, the text looks crisp. All of the other stuff that was still good about this is still there. Although, there is a little bit of shadow here. But I checked this on my actual Apple IIgs, and wouldn't you know it, there's exactly this little whitish, shadow there, as well as right here on the Apple IIgs. This text here, this is now readable. If you remember, that wasn't readable at all. This all looks great. And I'm like, but this is it. So the process that was followed here was really kind of extraordinary and interesting to me. And I want to say maybe this isn't the first time people have used this technique in emulator situations, i.e. to actually cycle through all possible inputs through some logic and then record the outputs and just emulate that way. That was the first time I've used this. And I think the results speak for themselves. Now, as best I can determine, this is exactly the output that you would get from an Apple IIgs with some of this old high-res mode stuff. So this is Choplifter. This is good. There's not a lot, in terms of the screen here, there's not a lot extra here. So let's reboot this. Let's speed it up. Let's fire up Apple Panic, which is some things to note here. These purple lines, the sides of the ladders, are really crisp, and the line is thin. The text at the bottom, while it's got color, it's not blurry, right? And again, this is exactly what it looks like on a 2GS. These bricks, the green bricks, those all have nice, clear, distinct boundaries. And then our little, deadly apple creatures here that are floating around also have nice, clear, thin lines. And the lines, these vertical lines are... This was really distinct. They're thin, right? They're not like several pixels wide. They're a pixel because there's only one dot turned on in that little area. So this looks great. Okay, let's go take a look at Total Replay. So this looks good. Let's just let it go into its slideshow, and we'll see some of these other old games. Again, text looks great. Thin lines, thin color lines are possible here. Crisp. Oh, let me slow down the... I was at 3 megahertz there. And this, text on high res was a common technique people had to do. There you go. Now, of course, the color, the color is different. And this is one complaint some folks have is some of the color choices the GS made. Like this is the same blue, this blue, and this blue. They're obviously not the same blue, but, that's how the GS represented it. They had to make some trade-offs. They wanted clear, distinct colors for text modes, and all of the old Apple II stuff got one of those colors. Um, yeah, all of these little orange dots are good, and this is seems like a Centipede ripoff here. That's cool. All right, maybe I can speed this up. Okay, yeah, this is good. This text is good. Um, that's pretty readable. There's still color fringe in a couple places. I mean, there's really no way to get around it entirely. This should be a double high res image. Alf. uh, yeah, lots of single, distinct, clear, individual dots here all over the place. And that's kind of what I would say is the distinction about the Apple IIgs approach to this versus what a variety of emulators did and have done. It really makes this stuff look good on what was modern on the Apple IIgs display and on modern displays. So let's see. I'm going to go ahead and let that run for a while. Um, so all of these updates are in a recent code push to GitHub. My project is public. You can grab the source code. You can check it out. My implementation of this high-res code is pretty straightforward. The whole routine here is 50 lines of code, and some of it's pretty repetitious. I could have done some of this with some inline functions and stuff, but at the end of the day, readability is worth a lot. So check it out. Let me know what you think. For my purposes, having this Apple IIgs emulator able to do a high-res to RGB conversion exactly like the Apple IIgs did. That's what I wanted. If I want to, I can still pop it back into NTSC mode. But I think I've achieved what I wanted, and it was through this weird process of this information was passed down from actual hardware into another hardware project, into a software project, and then it sat there for 30 years, and now it's in my code. So anyway, I hope you enjoyed this, and let's talk about other, things where there might be knowledge buried in old software from the past. I think that's a fascinating topic. Oh yeah, these lines are great. I could do this all day. Anyway, the guy who did this, the patent author, Robin Moore, I had actually thought about approaching him with questions, but sadly he passed away some years ago, and so whatever algorithm the Apple IIgs actually uses is lost in the mists of time, or maybe on some old hard drive at Apple, who knows. But the results of that algorithm are here and can stay with us now. All right. I need a new pair of shoes. So, like and subscribe and all that stuff. But until next time, have a good one.